how to calculate a z-score. Okay, so today, so you've already learned the empirical rules, so after this lesson, you should be able to know how to calculate a z-score, or you also hear it called standard units. Okay, so to use this data effectively, I'm basically going to go through the examples pretty quickly because I'm teaching to my computer, so I can't see student reactions. So the best way to use this video is to take notes. Okay, actually copy things down into your notebook, work the examples with me. Okay, since it's a video, you can pause it, so pause it often. Work the example a little bit, watch it a little bit more, and if you need to go back to and rewatch seconds of it, absolutely do that as well. Okay? So, started here. So do you remember the empirical rule? So it told us that if I have 68% of my data, it's going to fall between -1 and +1 standard deviations. If I have 95% of my data, it's going to fall between -2 and +2 standard deviations. And after that, like at least 99% of my data is going to fall between -3 and +3 standard deviations. Now remember that we already looked at the picture of all of this. It looked something like this. Where your mean was right here, and then 1 standard deviation out was right there, 2 was right there, and 3 was all the way at the end. Okay. So notice that if you look at between, 1 and -1 and +1 standard deviations, that is where the majority of your data lies. If you want to go out to 95% of your data, if your data falls between -1 and -2, or between +1 and +2, there is more data there, but there's not as much of it. Okay, so we broadened our range to 95%, but you still got to look at the standard deviation to know whether that's unusual or not. The same as if you go out to the 3s. Okay, so here is a graph of IQ scores. So if you look at the scores on an IQ test, you'll find that the mean IQ score is 100, and the standard deviation is 15. Okay? So that means that right down here in the middle is going to be a mean of 100. If I add 1 standard deviation, so if I go out to here, 100 plus 15 is going to be 150. And so, this is essentially 0 standard deviation, so this would be +1 standard deviations. Okay? Same if I go to the other side. So I can put my other line down here. This is now -1 standard deviation, so 100 minus 15 is going to be 85. And this is -1 standard deviations. Okay? Let's go out to this side. So here is 2 standard deviations above, so 100 plus 15. 15 is 115. 115 plus 15 is going to be 130. So that's +2 standard deviations. Let's keep going while we're out here. So here's 3 standard deviations, so I just add 15 to this one. So it's going to be 145. That's at +3. Okay, to the other side. So this was -1 standard deviation, so it's 100 minus 15. 85 minus 15 again is going to be 70. So that's going to be -2 standard deviations. And then all the way up to 3 standard deviations, well, 70 minus 15 is going to be 55. That's -3 standard deviations. Okay, so notice how we have this all nicely laid out. Also notice that there's kind of 2 different ways to talk about the scores at any given time. I can talk about the score that falls between 100 and 115, or I can talk about the score that falls between 0 and +1 standard deviations. Okay, that's an important note. Keep that in mind. So here is an inside test, so an emotional psychological test. Okay, for this test is scored, I believe, on a scale of 900 or something like that. And so the mean score is 500. That's an average person's inside score. And the standard deviation is 50. Okay, so I can do the same thing. So 500 is the mean, is basically 0 standard deviations. If I go out 1 standard deviation this way, it's going to be 500 plus 50. 550. That's +1. Go out another one. That's +50, so that's going to be 600. That's +2. And last but not least, all the way out here is going to be another 50. And that's going to be a +3 standard deviations. Okay, to the other side. -1 standard deviation is going to be 500 minus 50, so that's 450. All the way out here, minus another 50, that'll be 400. And last but not least, all the way out to here is 350. Okay. Notice for these, I can talk about the same thing. I can talk about a score that's between 500 and 550, and I can also talk about that score being between 0 and positive 1 standard deviation. Okay. So kind of two different ways to talk about a score. And the reason why I bring that up is because sometimes it's useful to not talk about the score. It's more useful to talk about the standard deviations. Like for example, let's say I have a person with an IQ of 115 and an MSI score of 490. Well, these are both scores that I would like to know how average this person is. Are they above average, below average, on par? What are they? If I look at their scores, I can figure it out eventually. I can say, okay, 115, oh, that's exactly one standard deviation above, so he's a little bit above average. MSI score of 490, that falls between 0 and -1, so he's about average on that. Okay. However, it would be really nice if I had just communicated both of those scores in terms of the number of standard deviations, because then it would have been immediately obvious whether this person was above average, below average, or on par for both of those. Okay, so that is why we have a z-score. A z-score basically communicates a score in terms of the standard deviations, or standard units is what we'll call it. Okay, so standard units is basically communicating a score in terms of standard deviations. Or another way to think about it is in relation to the sample. Okay? Basically, what a standards unit is doing is it's basically taking whatever the score is, standardizing it, making something that's across the board easy to compare. Kind of like we once did with percents. With percents, we like to make them into percents because it's hard to compare 46 girls and 56 guys if you didn't know how many girls and guys were surveyed. However, it's really easy to compare that. Oh, okay, 40% of girls and 30% of guys thought this, and so then you can actually make a reasonable comparison. Okay. The z-score is calculated by taking your data, whatever data point it is that you're wanting to find the z-score of, subtract off the mean, divide by the standard deviation. Okay. So this is your mean. This is your standard deviation. So for a certain test, the mean is 75 and the standard deviation is 3. What is the z-score for a person who scored an 80 on the test? And how unusual is this score? So, first of all, let's calculate the z-score. So my x is 80. My x bar, my mean, is 75. My standard deviation is 3. So I'm going to take 80 minus 75, all divided by 3. And so let's see here, that's going to be 5 divided by 3, which equals, I need a calculator. And for these, go ahead and round to 2 decimal places as a rule. Okay. So 1.67. So that is my z-score. Okay. Remember that z-scores are basically the standard deviation. So this is saying that this data point is almost 2 standard deviations above the mean. Okay. So how unusual is this score? It's a little unusual. Okay. Because it's definitely more than one standard deviation. But I mean, it's not completely out there or out 3 standard deviations. So it's a little unusual. So this person was slightly above average. Yeah, she scored 80 out of 100 on her first stats test and 85 out of 100 on her second stats test. Like any good stats teacher, they gave them the breakdown of the mean and standard deviation. So on the first exam, the mean was 70 and the standard deviation was 10. On the second exam, the mean was 80 and the standard deviation was 5. On which exam did Maria perform better when compared to the whole class? Okay. Well, first of all, we can make a little bit of, reasonable guessing here because we see that the standard deviation here is 5, the standard deviation here is 10. So this data was a a lot more spread out. So even though the mean is lower, there's a lot more variation in scores. Okay? Whereas this one, even though the mean is higher, there's a lot less variation in scores. So make sure you can get that picture in your head. Okay? So let's calculate the z-score for her first test. So for her first test, she had an 80. So x is going to be 80 minus the mean on the first test was 70. Divided by the standard deviation on the first test was 10. Okay, so it's going to be 10 over 10, exactly 1. Standard deviation, or the z-score, is exactly 1. On the second test, okay, her score was 85, minus the mean on that test was 80. The standard deviation was 5. Okay, so on this one, 5 divided by 5, so this one is 1. Hey, notice something here? 1, 1. Her standard deviation, her z-score, is exactly the same on both tests. So actually she performed equally well. Even though she got a higher score on her second test, second test she bumped it up to an 85. If you want to compare her to the rest of the class, she stayed right on par, no change. Okay. Mean daily high temps in San Francisco is 65, and the standard deviation is 8. On one day, the high temp was 49 degrees. What is this temp in standard units? And does this temp seem unusual? All right, so if they ask it for in standard units, they're asking for the z-score. Okay, so my x is 49 minus my x bar, my mean is 65, divided by my standard deviation, which is 8. Okay, so it's going to be 49 minus 65, which is negative 16, divided by 8, will be negative 2. Notice it is negative, and that's appropriate, right? Because 49 is going to fall below the mean, so it should be a negative standard deviation. So it's going to be negative 2 standard deviations. So this is somewhat unusual, right? I mean, it's not completely out there. It's within the realm of possibilities, but they don't get this temperature as often as something that would have fallen between -1 and +1 standard deviations. Okay. Let's try this one on. So this is the same thing, except for now my high temp is 35 degrees. Already we can say, okay, if 49 was a little unusual, then 35 should be pretty unusual, right? So let's go ahead and calculate the standard deviations, the z-score, the standard units, in order to have a complete idea of what that's going to be. Okay. So 5 is going to be my x minus my x bar, which is 65, divided by my standard units, which is 8. All right, so 35 minus 65, negative 30. So negative 30 divided by 8 is going to be negative 3.75. Remember that 99% of your data is supposed to fall between -3 and +3 standard deviations. This just blew by -3 by 0.75. Okay, so this is going to be highly unusual. Okay. All right, so at this time, please pull out a separate sheet of paper and do this exit slip. Once you're finished, turn it into my box. Remember, go back, watch anything that you would like to in order to figure this out, okay? Please make sure that you know how to calculate a z-score for a piece of data, okay? And have a wonderful day.